Okay, so continuing on to our this topic five, which is the external sewage system. So previously we covered on the internal sewerage system, so which is more of the drainage and of your building lah. So say this is connected to your water supply. So when we have a water input, then we will have a water output. So it can either be a black water or gray water lah. Usually when it pass through our building, if we use it for internally, then depending on the location of our sanitary appliances, then it might be a black water, which is having our sewage or surly, and then you'll be considered as a black water lah. It's contaminated with organic matter. And then if it's not contaminated with organic matter, if it's just for washing or showering, then we can consider that as a gray water. So to treat all of these, you need an external sewerage system. So once it exceeds our house, you have all this piping connecting it, connecting all these piping connecting and being and directing all our sewage to an external sewage system. So once it passed by an external sewage system, then it will exit into a body of water, either a river or the sea. So I think most of you guys have a look at this showcase on why and how external sewage system comes into play. So we have a lot of trial and error onto getting a good system and to reaching finally a good system. Okay, so talking about piping. So next off, we'll be talking about piping lah. So before we to reach this external sewage system, then we will need to install piping. So before that, previously, if you still remember on the video regarding London, so to have all this, to have proper transportation of sewerage or all this stuff out of our city, then we need a mode of transportation for all of them. So the mode of transportation will be the piping system. So as usual, when it comes to piping system, you have a few requirement of how we want to lay the pipe. So there's actually two methods when it comes to putting in the pipe into or installing the pipe. So what we can do is we can cut it open. So we call it an open cut method lah. So we can have an excavator here with a scoop, and then we can just open it up. We can just excavate it lah, meaning we cut a hole. So next will be a more fancy way, which is we also cutting a hole, but we only cutting it in one place and to another place. So for an open cut method, so this one won't be covered lah, just telling it to you. We will be excavating it from the whole length of the whole place that we want to install. So this is the first method of how we want to install something. So we excavate the whole length, which is the whole height of where we want to install our pipe. Let's say if this is 100 mm or even deeper, or 900 mm. So as mentioned here, if it's below a road. So you want to install it as deep as we can, but then when we install it very, very deep, then we actually need to excavate a lot of earth out, and then we need to fill it back in. So it's actually a lot of work if the pipe we need to install is deep. So there's actually a method nowadays with modernization. So we call it pipe jacking. So This one is just a different method of how pipe can be installed. So it's not here, just so you will know lah. Okay, if you go online and actually see that it's actually a very sophisticated method. So let me just drag a few picture. So if you can see here, so it's basically a machine having hydraulic jack. So this is part of the machine pushing the pipe into a hole. So instead of digging the whole way, then we can have something like this, having hydraulic jack pushing the pipe into another end. So we have a drive shaft and a reception shaft. And then we will have a pipe also which is trying to dig through or cut through the whole this length so that it's not filled with soil. You can wash all the soil out with another pump. So the idea is something like this. You have also a drilling head and then you have a pump. So as you drill through, slurry will come out and then we can pump it out. So what we end up with will be a nice pipe. So this is two types of method that we can use for pipe installation. One is a direct mode, which is a pipe, which is just an open cut, meaning we just cut open or we dig this entire line. And then this method is what we call a pipe jacking. So we just dig a drive shaft and then a reception drive shaft. And then we install our machine here and we push the pipe through. And when we reach here, then we have installed our pipe from one end A to end B. So this one is just for you guys to know lah. Okay, so requirement for how a pipe should be installed. We want it to be a simple layout, meaning we want it to be as straight as possible. We do not want a lot of bend. And then manhole to kept to a minimum. So where to install our manhole will be whenever we have an intersection or if you have a length of a too long length, meaning we have about 1 km in length. So whenever we have an intersection, we want to put one manhole here so that we can check for any for any leakages or what. And then if you have a very, very long length in between manhole to manhole, intersection to intersection, then we can put in a few more for inspection and checking So manhole are there for inspection and checking. Okay, next straight line. So inspection and cleaning. So next we want to have our pipe. This is very important. Whenever we install a sewerage pipe, we do not have it on a straight line. Meaning when we install it underneath, let's say we cut our surfaces, we are on top here. So we don't put our pipe in a straight line. So if it's on a straight line, it cannot flow. The inside of the sewerage inside our pipe cannot flow. So it will just stagnant here. So for it to be a self-cleaning gradient, we want it to be at a slightly slanting position. So just for example, you want it to be something like this, slanting. So when you have sewerage, then it will go down via gravity. So gravity will pull it down, then everything will just go down, and then nothing will be stuck to the pipe. So this is what is called a self-cleaning gradient. So let's say if you have a sewerage treatment here, external treatment plant, STP. So we call it STP for short, sewerage treatment plant. So we have a house here, and then we have a house here. So installation of all the pipe from house to house will be at different depth lah, depending on where we are at. So from the house, it can be from just 600. So from here, it also can be from 600. But then the depth at here will have to be at about 700. So 700 just for example sake. Okay, let's say for example here is a very long distance. It's already about at 800. So when it comes to here, then we have no choice but to go even deeper. Let's say here and here is the same. So even though this is 600, when they're exiting from the house, because of the gradient that here is already is already at a self-cleansing gradient of 600 mm, then here we'll have to go 800. Then here we'll have to go even deeper. And then when it comes to our STP here, let's say this is also the same distance, then it might go to 1 km. And then here maybe it will be 1050 mm. So pipe going towards the STP will always be increasing in depth to fulfill this self-cleaning gradient, because we don't want to install any pump and we want to ensure that all this pipe there is nothing stuck there. So this is just an idea on this. So self-cleaning gradient is very important when it comes to requirement to sewage pipe. And then for this one and this one is about the same. Okay, installing of pipe, we want it to be as deep as possible so we don't accidentally dig our pipe out. So usually when we have a main cover, we will have a we have a word there. Usually it's called what is it called? Manhole cover. Okay, so in Malaysia, we have something like this. So you'll be called in Malay you have a kubahan here, and then you know that this is a excess of main cover for our piping. So different district they will have different access. Sometimes it might look like this. Sometimes, but nowadays we have standardization meaning we have a standard cover, which is here. Okay, then next. Okay, so from here to here, this is a standard requirement of how we should install piping. And then from the bottom tree here, so this is like a rule that we shouldn't install any pipe underneath a building. So if you use the first method, which is the open cut method, we cannot do it because we cannot excavate the land underneath a building. So for the second method, we can use pipe jacking to do it, but this is not recommended because if we put it near to our foundation, which is we have a building here. So underneath our building, we will have our, let's say, pad footing. So this is what we call a pad footing here, a pad footing. And then underneath our pad footing, we will have our foundation. So we do not want to have our pipe going through here. So if you have a pipe going through here, it will be very dangerous for our building So in case our pipe leak, then it will wet the area here. So once it leak, water will escape from the pipe. It will leak to the surrounding soil. And then because once the soil is wet, give me a moment. Give you a moment. Okay, so sorry about the noise. So, why do we not want to have a pipe underneath a building? Is because once a pipe leak. Okay. Okay, so once a pipe leak, they actually wet the surrounding soil. So when a soil is wet, they essentially lose their strength, meaning they might be a collapse because if we take look at how a soil is like when it's dry, then it is able to maintain its shape. So soil actually they have a lot of void inside them lah. So if you were to wet the area of a soil, then they actually loses their strength. And then when a foundation loses the strength, then it will collapse lah. The building will collapse. Okay, so ideal example of how a slope or how a building might collapse will be when we have rain or we have very heavy rain, and then you see news lah that once a heavy rainstorm come, then our slope will collapse. So same reasoning lah that once you wet soil with a lot of water, they actually lose their structural integrity, meaning they become soft, so they are not solid and strong anymore. So when you wet something with water, especially soil, it will cause them to soften up and not have any structural strength, lah, meaning it's not able to held its shape together, and then it will lose its strength. And then if we have anything man-made like buildings or even roads being supported by our this type of soil strength, so this is where the problem will come into play lah. We do not want water any near our foundation. Okay, so this is a reasoning. And then yeah, so we do not want pipes near trees because inside our sewage pipe there's a lot of good nutrient for them. So naturally the tree root, they will try to go towards the pipe, and then they will damage the pipe. Okay, then after that we want to use a standard material for our piping, and if possible we want to use flexible joiner. Okay, on different material. So when it comes to laying the pipe outside, usually we use this verified clay. So in short, we call it a VCP lah. So this is all VCP pipe. So it's actually a clay pipe. This is what you usually find on the roadside. It's a brown color lah. So nowadays you're all COVID. So if you were to come to UC and study, and then maybe if you travel around KL, you might see a lot of this pipe just being laid around or beside the road. So you see a lot of this pipe being put beside the road, and you know lah that this is what we will use to transport our sewage. So this one will go into our ground. So either by pipe jacking lah, or even open cut. So in the city, like especially in KL, you find that we use a lot of pipe jacking method. So this is because a lot of the place is already filled, meaning we cannot simply just excavate lah. So if we excavate, then you have a lot of soil. So if it comes to a new development, meaning a new city being developed and there's nobody there, meaning there's no public people in the area, then we can easily use the open cut method. But in a city, we cannot do that. So usually the area will be barricade, meaning you have our cone and everything to so that people do not access when you are doing work. But in a city, if you notice that they have some barricade, lah, the red and white barricade or even the concrete barricade. So that is where they are doing our pipe jacking works. Lah. So this is where if you see something like this next to the road, usually they just put it beside the road lah. Then you know lah, we are installing new sewage piping system. So this is what we usually use when we are outside. Okay, when it comes to the internal of our STP, we'll be using sometimes a steel pipe, but most of the time we'll be using cast iron lah, because it lasts longer. So after 10 years, no problem, but you have to make sure that the pipe is filled completely. So that's why, due to this, if you don't fill it completely, then it might have some corrosion. So due to these circumstances or this sort of condition, steel pipe and cast iron, they are not used outside because they are metal, so it's expensive. And you do not want to lay a very big network of all this steel material. So this, when we are using steel, it's only in internal of our STP, meaning it's only inside our sewage treatment plant where we can close it off, put fencing, and then install all the piping. So outside, we can also have concrete pipe or asbestos cement. And then sometimes in our house, usually in our house, you have plastic lah. So you can have a UPVC, HDPE. This is all different composition of chemical of how plastic can be made from. So they are all resilient to acid attack. And yeah, so this will be used for our internal house. And then this steel and cast iron, but usually we use cast iron for our sewage treatment plant itself. And then for outside, we can have this three. So just an idea of where this common sewage material can be used at, or they can be, or when, or the location where they are selected to be used. So due to cost, and then ease of usage, and then for length of services, so how long the services can be used and where's the condition or where we can put it at. So you can select different material to be used as our piping system. Okay, so for our manhole, we can have brick. You can have it made out of brick, but this is only for a very shallow manhole. But usually when it comes to a city, because of the very long length of our pipe laying network, so with this requirement of, if we have a road, we put it 900 mm, which is close to 1 km. It's actually, which is close to 1 meter. So half of our body length. So imagine from our house, it starts from 1 meter, half of our, a bit more than half of our length of our body lah. So when we reach to our STP, we have a very long network of pipe when it reach to the STP, meaning when it ends at the sewage treatment plant. So easily from our ground, it can go to up to 9 meter depth. So having brick manhole isn't very good lah, because this is not strong. Brick is not strong. So if it's just a very shallow, then we can have a brick manhole. But in the case of our pipe going very very deep, then usually most of the time we have a concrete lah, like this. So they are made out of different width, but then essentially it's all precast concrete. So then at the end we have our pipe lah here. So so an example of how a manhole will look like will be something like this. You have our handle for us to go down, and then we have a lot of concrete lah surrounding us. So this one will be a small entrance, the size of a manhole, and then as we go deeper, there will be a bigger shaft lah, so that we can fit our entire body of people inside when it's required lah to service the piping. So if it's too deep, then by law lah, this is for safety sake, we actually have a landing slab. So this is a break lah, a breaker. Okay, so this landing slab serve two purposes lah. The first will be to ensure that it's not a one-way trip down, and then after that, we don't want people, if accidentally someone were to slip and fall, then they won't fall all the way from the highest part to the lowest part lah. So just an idea lah to you guys that whenever we have a very very deep or a very very long climb, then if you have a look at our house, for example, let's say for a landed house, if you have a flight of stairs, you notice that we have a flight of stairs, you notice that there will be a landing, and then after that you will continue back again. So this one is a requirement. So it's a design requirement lah. So in our house, if you were to count, there should be about 12 to 13 steps. That is the maximum length of that's a general requirement of how much step you can put on a flight of stairs before you require a landing. So here, this is called a landing. So same case with a ladder or some sort of like this. So about 2 to 3 meter of climbing, then we need to actually provide a landing slab or landing platform lah. We call it a landing platform. So this is to ensure that we can have a safe, we can have a rest, or we can break the action lah of climbing and going up. And then also as a safety measure lah, if we were to slip, then we won't fall too far down. Okay, so this is just a requirement lah of how it can be done. Okay, when it comes to treating sewerage, so we go into sewerage, there's actually 3 primary stages. So we have our first primary, secondary, and tertiary. So when it comes to treating sewerage, our Malaysia, our treatment plant is actually very good lah. So if we look at other country, so if you have a chance to travel to other country, you might notice that they might have different practices. Like let's say for example, Thailand and China. So in Thailand and China, they actually, in the toilet, they actually got let's say a bin. So in a bin, beside the WC, you see a lot of tissue paper lah. So the idea behind why they are practicing this is because their sewage treatment plant is not made to accept or to transport this tissue lah. So maybe their piping, their lid is not big enough, and then finally when it goes towards the external sewage treatment plant, they are not so their treatment plant isn't as complete as ours lah. So different country they will have different setup, but usually they will follow this sort of arrangement. Okay, when it comes to in Malaysia, so this is how sewage treatment is built lah, or the different treatment. This is how we have it in Malaysia. So as mentioned, when the sewage pipe arrive at the sewage treatment plant, it will actually be at a very, very deep depth due to the requirement of them needing to be self-cleaning gradient. So typically, they can be about 9 or 6 to 9 meters lah, in depth, depending on how far the this sewage treatment plant need to service. So how many house they need to be able to service. So when it comes to a development, let's say we have a residential building. So a sewage treatment plant is rated to be able to service how many people lah. So then from there, we are able to lay the pipe, or we are able to do pipe jacking and then lay down all the pipe towards at a self-grading, as a self-cleaning gradient towards this sewage treatment plant. So first off, we'll end it at the pumping station. But before that, we actually have a primary, preliminary or primary treatment lah. So here, although it's not being shown, after it passed by the first pumping station, which is to pump from a very, very deep 9-meter depth pipe up towards our ground level, or at the highest point lah. So the first process that we have in our primary treatment, although here it's not shown, is a filtering system lah, meaning we have a filter to filter out all the rubbish from our sewerage, organic or inorganic. Then after that, we will be passing through all the processes from the primary to the secondary, and then after that, finally to disinfection. So here, during the primary stage, we want to separate as much organic material and inorganic material as possible before allowing it into the secondary stages. So here, usually we pass by quite a long process, meaning you let it flow so that any suspending material, they'll have time to settle down at the bottom. So this is for the organic material, which is our sewerage, to settle at the bottom to form some sort of a sludge, we call it. So it's a very thick mud-like material, which we can be removed out to us. We can be removed out to another. Okay. So usually when we have a primary, you remove it to a sludge thickener or sand drying bed. So this is something we call like a waste sludge thickener, but we can also call it a sand drying bed lah. It's essentially just a structure with sand, and then we let it dry. So some sort of like a baking lah, because our weather in Malaysia is so hot. We can allow the sludge to further dry, and then after that, the sludge can be removed to become fertilizer. Okay, so this is the first primary processes, meaning we want to try to separate as much as possible anything suspending inside our sewerage. And then once it passed through here, then we go towards secondary treatment. So we allow the time, and we allow the time and we allow it to slowly move through the different stages. And then when it comes to our, let's say, third tank, so we come to our third tank. So we don't have much of the sludge anymore, but there's still a lot of stuff inside our water. So we want to treat it so that it's clean enough to be discharged back into our river. So from here, because we still have a lot of stuff, we want to treat it biologically, meaning there's still a lot of bacteria and organic material floating inside our water. So biological treatment when it comes to Malaysia is just simply by pumping in air or we are disturbing the surface. So once we disturb the surface, we're actually promoting more oxygen to go into this sewerage. So when there's more oxygen, bacteria will start to break down all this material. They'll start to reproduce, break down, and then once we pass by these stages, maybe let's say for about 12 hours to 24 hours, once all the material is fully decomposed, then we go to our final settling. So you allow it to settle in another tank for, let's say, about 6 to 12 hours, and then you allow the remaining sludge to go to the bottom. Then it can be also taken to the sand drying bag or the waste sludge thickener. And then the remaining clear water, we can move it to our another contact basin, another tank where we can put in chlorine and discharge it out. So usually when you have a sewage treatment plant, if possible, we don't want to have this So this is just an example sake But when it comes to having a pump, like we learned in our previous topic, having a pump is expensive because we need to operate it. There will be monthly bill, and then we need to have also a standby pump in case that pump spoil. So there's a lot of criteria when we need to have a pump, especially when it comes to sewage treatment plant. So to reduce the cost of maintaining and operating, and also to make it all automatic, we just want to have, if possible, just a pump at the beginning of the station, and not just one We need to have also a standby. So if this breaks down, we can use the standby pump to pump out the sewage from the pumping station. So if we don't have that, then it will be very disastrous. So if our pump in use spoil, our standby pump also spoil, then it will be a disastrous situation because if everyone try to flush their toilet, so this one will be backup because the pump is not working, they are not pumping the sewage out. So all of them will be accumulated, and then it will be shoot out from. We won't be able to flush our water, our wastage. Okay, so although not shown, there will be actually a screener. So there will be a screening. Let's see. So this is how a screen can look like. But let me find a better picture. Okay, so usually when it comes to screening, we have a very fancy screener. So yeah, so it's something like this. So a screen which is able to rotate. So it's actually run by machine. So as sewerage come into our goes through this piping or our outlet, then we can have a screener. So this screener will remove any organic or inorganic, very solid material lah, out from our piping, out from our treatment plant. Yeah. So usually when you have this sort of screener, they will be removing the rubbish out from the STP into a waste bin. So let's see if I can find a good picture to show you guys. Yeah, so this is a side view of how that screener will look like. So they will actually have another shaft. So the rubbish will be picked up by this motor here on top. It will be rotating the filter. And then when it reach the top, they will actually be able to dump the rubbish out through this chute. So at the bottom here, there should be a waste bin lah. Okay. Yeah. Okay, this is a better example lah. So something like this there will be a bin here. So this one is not shown here, but just to give you an idea lah. Okay, so once we pass by the primary, then secondary, as mentioned, will be to allow the bacteria to eat out all the harmful content inside our STP. So when it comes to STP, in Malaysia, we are very fortunate that all our sewage is we have a system in place. So all our sewage, we have a system in place which is to go towards external sewage treatment. But then when it comes to other country, they might not have this sort of services. So for that, they will need to install maybe a septic tank, or we call this a cesspool. It can be something like this, a cesspool. So here, this one is an in-house tank. So this is actually a STP. This is still an external sewage treatment plant. So usually this one, you won't find it for individual, meaning your own one. When it comes to individual, let's say for example in US or even in Korea, they do not have a strict method by the government on how they can treat sewage. So in Malaysia, most of the development has been mandated that we need to have a external sewage treatment plant. So this is, but then nowadays, maybe it's different for other country. Like, okay, if back in the olden days, let's say if your house is very, very old, for example, maybe they are built in the 70s or 80s, then you might have a septic tank, something like this in place, or even a cesspool. So these are not so good in terms of, let's say for a septic tank, they need to be serviced, meaning maybe in 10 years time, or maybe 5 years time, or 2 years time, depending on the size and how many people using the toilet. You will need to call the sewage treatment plant or someone in charge to come and empty your tank. So you have to pay a fees let's say maybe about, for example in US, they are paying about 200 to around 2 to 300 USD to get a guy to come and clear their tank. So this is an idea If you have a septic tank, which is something like this, then we need to clear it regularly, maybe 2 to 3 years once. If you have a cesspool, this is already illegal. So why is it illegal? Because we are allowing the fluid to go out. So this is the old idea of how a cesspool is like. We allow it to go out. So the new idea, we have a different configuration, which I'll show you in a later slide. Okay, and then for this, we have our in-house tank. So this in-house tank is an old system of how a STP can be like. So it's just basically passing through from point A to a point B to out, from inlet to output. So in between there, we want to allow all the things to settle, meaning this is all done without any movement of the sewage. So we hope the bacteria inside will uh, will be able to eat up all the bad stuff and then allow all the bad stuff to settle, the sludge to settle. But this method, this is old technology lah. This in-house tank is old technology. It's not in use anymore because there's a downside to this method. So, for example, if you have very very high usage of water, or if a lot of wastage is being, a lot of sewage is being directed into this in-house tank, then this system will fail. Why? Because we put in too much, then before it's able to settle down and be digested by the bacteria, then it will actually flow out lah. So this is old technology lah. Let's say maybe about 30 years ago when we first started STP, then we might have this. But nowadays we have more of this sort of process to ensure that the sewage is properly treated. Okay, I think I go on long enough. So let me finish this. Then let me finish this few slides. Then we have a break for a while. Okay, so next off, this is also actually what we can what overseas call a cesspool. So it's also very close to a septic tank. Okay, it can also be called a cesspool. So as similar to a septic tank, we can have our waste coming into here, and then we have all our this inside being filled here. But then because this is a small pool, a small tank, then it needs to be emptied out regularly. Okay, so the previous method of all this treatment are all without oxygen, meaning we do not disturb them. So they are called anaerobic. And then in our external sewage treatment, we call this as an aerobic system, meaning we are disturbing the surface and we are promoting more oxygen into our sewage. So it can be a suspended growth system or fixed film growth system. So this one is just having a filter. Either it's a fixed filter or is it a suspended filter. And then the second, and then besides that, we have this, which is a blower or pump, which can pump in air into our sewage. Okay, so next off, so different method of how we can promote more oxygen into our sewage. We can have a mechanical arm moving around, disturbing the upper surface, or we can have a pump. where it can pump out and disturb the surface, or even a motor where we have a rod to mix it around. Okay, so next then we have our septic tank. Okay, so a septic tank will be there if you cannot connect any houses to the main sewer system, but usually you will not have that lah. Usually we will connect all our building to a sub sewer system, meaning instead of having one very big sewerage system servicing the whole country, you have different minor or smaller sewerage system lah, having it here and there. So if you notice, then there will be sewage treatment system in some corner of your taman. So usually this one we don't, in Malaysia we do not have it anymore lah. We want it to connect it to a centralized system. So no matter how small, we want it to be not not giving the responsibility to us public lah. Because if we were to have it to be serviced monthly or even yearly by ourselves, usually if it's up to us, then we don't do it lah. So if you don't do it, then there will be problem of this coming out or maybe leaking after years. Then it will cost us a lot of money. Then if we can ignore it, we will ignore it. So if to not allow this sort of thing to happen, we connect all of them to our sewage treatment plant lah. Okay, so this talks about how a septic tank will be like. So when it comes to a normal a septic tank, or in other places they might call it a cesspool. So they will want to allow the liquid and the sludge to separate, and then if it comes to a more advanced or more better system, let's say in US, they have a better system where they have a own internal system where they can try to separate the sludge to the bottom, and then all this water they want to pump it into an irrigation field. So it's like their own septic tank system lah. So we have our sludge at the bottom, and then in between we have our more clearer liquid, and then anything that is light they can float to the top. We call it as a scum. So the remaining liquid, we can have it pump in and out from this tank to an irrigation field. So we don't have this in Malaysia lah, because this one needs to be maintained, and then it needs to be serviced lah, meaning the sludge will slowly accumulate. Let's say in about 1 to 2 years, you need to call someone to come and service or remove this sludge out from your tank. So in Malaysia we don't have, but if you were to have a look at Facebook or YouTube, you'll see a lot of you will be able to see video of people coming and removing the sewage inside this tank. So you can treat small volume. Is although it's said low in construction and maintenance costs, when it's installing this sort of system, it's not cheap lah, because you need to have a tank here, all the piping connecting to each other, and then you want to have an irrigation field, meaning the liquid you will need to be able to flow to a large drain field. Okay, so it's not a very good system because it's just a small system. So you're hoping that all the sewage get absorbed into our soil layer. Essentially, we are trying to use the soil as a filtering system lah, to allow the sewage to go back into our ground. So we do not, in Malaysia, we don't want to have this because if we have a very high volume of sewage, then it will actually pollute our surrounding groundwater. So we don't want to drink what we discharge out from our house. Okay, so let's stop here